Hi, I'm Bob Dobkin. I'm the CTO at Linear and one of the founders. And I want to talk about power supplies less than half a volt. Most people talk about high voltage supplies. I'm talking about low voltage supplies because there's some applications for them that need to be fulfilled. If you look at most of today's power supplies, they have a reference of 0.6 volts, which means the output voltage has to be greater than 0.6 volts. In 2007, we came out with a new architecture of a current source reference, and that makes it easy for the output of a power supply to go down to 0 volts. If you look at the next generation of core voltages or the next generation of FPGAs, they are made with a finer line width process, and some of those cores go down to 0.5 or even 0.4 volts when they're running at high frequency and high density. So there will be a need for lower power supplies. Biological supplies are always less than a volt. A lot of test systems and biasing is needed to get down below a volt. Power supplies are basically a power op-amp. And this is a basic op-amp circuit that's used in most of the power supplies. We have an op-amp with gain resistors and a reference. This means that the output is equal to the reference plus the reference times the ratio of the feedback resistors. If the feedback resistors come down to 0, then the output will go to the reference voltage. That's the lowest output voltage you can have from this system. Most of those references are set at between 0.6 and 0.8 volts, so that limits how low the output can go, although we do have some linear regulators with a 0.2 volt reference. Our new architecture for regulators uses a current source reference. The current source reference feeds a current through a resistor, and the amplifier is set up as a follower. So the output of the amplifier is the same as our reference voltage across the reference resistor. If the resistor goes to 0, our output goes to 0. This architecture has a couple of other really good features. The amplifier is always running at the same gain, so the regulation is independent of output voltage, and you can parallel them. You tie the set resistors together, and the outputs are within a few millivolts of each other, so that you can tie them together with a very small ballast resistor. This is an actual regulator. It has a current source reference and a linear pass transistor. The current source reference generates a reference for our voltage follower, and we have two power inputs to the voltage follower. One that goes to the pass transistor and one that goes to our control circuitry. We separate the power supplies because then we can make the power to the pass transistor much lower. By having the voltage to the pass transistor just a few hundred millivolts above our output, we reduce our dissipation and we end up with good regulation because we have plenty of voltage on the control circuit. These circuits all need an output resistor, although it's not shown here, to get down to 0 because the quiescent current flows out of the output terminal. If we want to use a switching regulator to generate low voltages, we have some devices that we call rail-to-rail switching regulators. The output goes very close to the input voltage and almost down to 0, within 20 millivolts of 0. This is a 4-amp rail-to-rail switching regulator. Single resistor sets the output. We have a monitor pins so we can look at the output current. And our output will go anywhere between ground and our input supply. This is good for applications where you need a low output voltage, although at very low outputs, the ripple may be an appreciable percentage of our output voltage. If we need high current, we can use a circuit like this where we use 4 linear regulators in parallel to get 12 amps output. We have a tracking pre-regulator that keeps the voltage across the pass transistors at less than 0.6 volts. That way we have low power dissipation, we can go all the way down to 0, and we have very low ripple at the output. Other types of devices that go down to 0, we have negative regulators that do that, and they can be used for bias circuits or applications where you need a negative output. For more information on these devices, visit us at linear.com. Thank you.